Breaker trip settings. The protection settings of breakers are detailed. Main trip settings in detail. Thermal-magnetic trip setting and electronic trip setting. Thermal-magnetic trip setting. If the current flow exceeds a predetermined amount, the bimetallic contact bends due to heat, which activates the tripping mechanism. Bimetallic strip is made of two different metals bonded together that bend when heated. The strip bends towards the metal with the lower coefficient of thermal expansion. Thermal element overload protection. Bimetallic contacts are used in thermal-magnetic trip protection. Bimetallic strip heats up with excessive current, causing it to bend and mechanically trip the breaker, offering protection against overloads. Overheating causes the strip to bend and trip a switch connector, which interrupts the current. A thermal-magnetic trip unit in a breaker combines bimetallic system for overload trip and electromagnetic elements for short-circuit protection. Magnetic elements short-circuit protection. An electromagnet is used to detect sudden, large current spikes and triggers an instantaneous trip, preventing damage from high-fault currents. In normal conditions, the magnetic field will be stable, and so no changes in the latch attached to the trip bar. A sudden high surge of current is created in the circuit due to a short circuit, and a strong magnetic field occurs in the coil. This field instantly pulls an armature associated to the trip bar. Immediately, an instantaneous tripping happens to the breaker to clear large faults rapidly. IR, long-time current setting for continuous operation. A breaker trips when the current exceeds the limit. 3 settings are available, such as 0.8, 0.9, and 1. Setting of 0.8 given for a 250 amp MCCB. The maximum current available is 250 times 0.8 equals 200 amp, so that the MCCB trips when the current exceeds the limit of 200 amp due to overload. IM, thermal magnetic setting for short circuit protection. The breaker trips when the current reaches the limit. Settings are available in 6 steps, that is, 5 to 10 times of the current. For example, if the setting of 8 times 200 amp is given, the MCCB trips in a short circuit of 1600 amp. That is, 200 times 8 equals 1600 amp. Welcome to my channel. This video is related to important trip settings in breakers. Electronic trip settings. Electronic circuits for tripping short circuit, overload, and instantaneous protection of the breaker is controlled by an electromagnetic coil with CTs. IO overload trip setting. IN equals normal current, that is 250 amp. Settings are available 0.5 to 1 in 6 steps. If we set IO as 0.8 of IN is equal to 200 amp, 0.8 times 250 equals 200 amp, so that the maximum current available in this breaker is 200 amp for long-term use. If it exceeds the limit, the breaker will trip in overload. IR. This is used as a final turning for I/O to get an accurate tripping current. Setting available 0.8 to 1 times of I/O in 8 steps. For example, IR set to 0.88 of I/O, that is 176 amp, that is 200 times 0.88 equals 176 amp. If we do not using the fine setting, place the pointer to 1. ISD. This setting is for short-term protection. Settings available 2 to 10 times of IR in 8 steps. For example, setting applied to 5 times of IR and is equals to 880 amp. That is 176 times 5 equals 880 amp. Under normal conditions, the CT coil generates only a low electric field, so the breaker does not trip. When a short circuit or sudden fault occurs, a high current flows in the CT and a strong magnetic field is generated in the coil. This moves the plunger in the coil and instantly the circuit trips. Normal short-time protection tripping time shall be 0.2 to 0.5 seconds. Different types of protections are available in electronic trip units. It depends upon the manufacturer of breakers. Two important settings given here, that is instantaneous protection trip, II, and earth fault protection, IG. II instantaneous trip, short time protection. Settings available from 1.5 to 11 times of in. In a 400 amp breaker, if we set 6 times of IN, the breaker will trip instantaneously at 2400 amp with no delay. That is 400 times 6 equals 2400 amp. IG, earth protection. The current settings are available from 0.2 to 1 times of in 8 steps. In a 400 amp breaker, we set 0.4 times of IN, the breaker will trip in 160 amp. That is 400 times 0.4 equals 160 A. Tripping time available in 4 steps from 0.1 to 0.4 seconds. We will meet again with a new video. Thank you for watching my channel.